Hello and welcome to our first lesson of second semester, our first real lesson of second semester, Pythagorean theorem and its converse. So there's a little bit of new stuff here, but a lot of this is review. So what I'm hoping you'll be able to tell by today is how to find side lengths using the Pythagorean theorem, which you might know already. But then the new part is probably classifying triangles using the Pythagorean theorem. So let's recall real quick, what is the Pythagorean theorem? When I say this, a squared plus b squared equals c squared, that should jog your memory. You've probably been doing this since middle school. So let's try it real quick. Very basic problem. A right triangle has side lengths of 4 feet and 8 feet. Find the length of the hypotenuse. Well, the hypotenuse is always the longest side. So if you don't have to draw this out, but if you want to draw it out, you can. One of the legs is 4, one of the other legs is 8. It doesn't matter which one goes where. You're looking for this one. Okay. We're going to give our answer in simplest radical form and round it to the nearest tenth. So a is 4. We'll say a is 4. So 4 squared plus 8 squared equals my missing side squared. So 16 is 4 squared. 8 squared is 64. And then add those together, you get 80 equals x squared. Take the square root, and you get what we had gone over yesterday with the first video, simplifying radicals. So simplify this square root of 80. We do it pretty quickly here. 8 and 10, 4 and 2, 2 and 2, 4 and 4, 2 and 2, 2 and 2. Oh, wait, I read that as 16. That's why it's important to be able to read your own handwriting. It's not a 16, that is a 10. And 10 breaks down to 5 and 2. There we go. That's better. So I've got 4 2's. So it's a pair of 2's and another pair of 2's. That's a 4 on the outside, radical 5. And then if you pull out a calculator to get the rounded number, you can do square root of 80. You don't have to actually type 4 radical 5, but if you want to, you can. I'm going to do square root of 80. I get 8.9. So the rounded version or rounded answer of this one is 8.9. Okay. All right. Now, a Pythagorean triple. What is a Pythagorean triple? A Pythagorean triple is a set of 3 numbers that represent side lengths of a right triangle. To see if a set of numbers is a Pythagorean triple, you just simply plug them into the Pythagorean theorem. So, is 8, 16, and 20 a Pythagorean triple? So we just plug it in. Make sure you get your biggest side, which is 20, as the hypotenuse or potential hypotenuse. So 8 squared plus 16 squared. Does that equal 20 squared? So just figure that out. 8 squared is 64. 16 squared is 300, or sorry, 16 squared is 256. So 64 plus 256 is 320. 20 squared is 400. Does 320 equal 400? It does not. So my conclusion is no, this is not a right triangle. This is not a Pythagorean triple. Okay. Next one. Try it yourself. See what you think. Okay. Hopefully you answered that question right that popped up on the screen. But a lot of people will make a mistake of going 5 squared plus 13 squared and then 12 squared over here. Be careful of that. That's not right because you need the biggest side by itself. So 12's got to go here and 13's got to go here. So that's 25 plus 144, which is 169. 13 squared is also 169. So yes, these are equal. And yes, this is a Pythagorean triple. Okay, well, if it is a Pythagorean triple, great. You know it's a right triangle then. But what happens if it's not? If a set of numbers does not represent a Pythagorean triple, we can classify the triangle by its angles. We can actually go a step further. All right. If c squared is bigger, so the key thing here is put your larger one on the left here. I think that helps a lot. You don't have to, but it does help a lot here. If c squared is greater than a squared plus b squared, then the triangle is obtuse. And then if c squared is less than a squared plus b squared, then it's a cube. All right, so classify the triangle by its angles with side lengths 4, 6, and 7. So 7's got to be the biggest side. So I'm going to do 4 squared. Actually, I'm going to, now you're taking my own advice here. I'm going to do 7 squared first. I'm going to put that one by itself. The largest side first. And then the other two I'm going to put over here. So 49. 4 squared is 16. 6 squared is 36. So I get 49 and 52. So c squared is smaller. So if c squared is smaller, it's an acute triangle. All right. Try the next one. All right. My biggest side here is 17. So 17 squared, 8 squared plus 15 squared. 17 squared is 289. 8 squared is 64 plus 225. That's a 4, not a. So then 289. And the other side is also 289. These are equal. If they're equal, it's a right triangle. Okay. All right. On to the back side. Some applications. A baseball diamond is actually a square with 90 feet sides. Okay. How far to the nearest foot does the catcher have to throw the baseball if he is throwing from home plate to second base? So if you haven't seen a baseball diamond, look like that. Here's home. Here's second. So the pitcher or the catcher has to throw it from there to there. This is 90 and this is 90. Okay. And these are right angles, all right angles. So the Pythagorean theorem is allowed here. So pretty straightforward, I think. 90 squared plus 90 squared equals how far the catcher has to throw it, which we'll call it x squared. So that's 8100 plus 8100 equals x squared. 8100 plus 8100 is 16200. And when I get a big number like that, I'm going to go ahead and type it in the calculator, square root of that number, which, by the way, I did just want to the nearest foot. So it's not a good number when you type it in, but I went to the nearest foot, so I can just say about 127 feet is how far the catcher has to throw the ball. Okay. Next one's not really an application, but it's not as straightforward as you might think. Find the value of the variable in the triangle below. In this one, that H is in the middle of a triangle, but that triangle is two separate right triangles. Now, a lot of people are going to want to cut that 40 in half and say 20 and 20. In this case, it happens to be correct, but why? This goes back to what we learned in first semester. We got a right triangle here on the left. Because those two angles form a line, and one of them's a right angle, the other one has to add up to 180, so the other one has to be a right angle. So there's two right triangles. This line is congruent to itself by the reflexive property, and it's given that my hypotenuses are equal, which are these two. So I have a hypotenuse that's equal to the hypotenuse in another triangle. I've got a leg that's equal. Therefore, HL theorem says that these two triangles are the same. And now I can say CP, CTC, and these are both 20. From here, it shouldn't be too bad. Now I'm just going to look at one of these triangles. This is 20, this is 29, and I'm looking for this. H is a leg, so I'm going to leave that one with the 20. Make sure you're putting them in the right spots. So H squared plus 400 equals whatever 29 squared is, 841. Subtract 400. I get H squared equals 441. Take the square root of that, and you get 21. Okay. Last one. Find the lengths of the indicated sides If the area of triangle ABC is 24 feet squared, give your answer in simplest radical form, then classify it by its angle. So there's a lot to do in this problem. The area of triangle ABC is 24. The area is 1/2 base times height. We will learn that in the future. You should know that from probably late elementary or middle school, the area of a triangle. But I'm going to use that to help me find my missing piece. So I'm going to put 24 in for the area because I know that. The base is the whole bottom here. Now the whole bottom is 12, 4 plus 8. I don't know what the height is yet, but I'm going to figure that out. So 1/2 of 12 is 6. Divide by 6, I get my height is 4. Now I can use the Pythagorean theorem to find AB and the Pythagorean theorem to find BC. I'm going to do those twice. So let's change colors here. I'm going to do the triangle on the left with red. So that's 4 squared plus 4 squared equals AB squared. So I'm going to get 16 plus 16. Let's call it X here. So 32. Square root of 32 is, I'm going to save us some time. I'm just going to do 4 radical 2. You will be needing to know how to do that. If you're not sure how to do that yet, work it out. Okay. And now I'm going to do BC, call it Y. So I have 4 squared plus 8 squared equals Y squared. It's actually the same as the first problem we did on this video. Y squared equals 80. Square root of 80 is 4 radical 5. And now we want to classify triangle ABC. Now, this can be a little tricky here. So AB is 4 radical 2. BC is 4 radical 5. And AC is 12. So I've got my 3 side lengths are 4 radical 2, 4 radical 5, and 12. Which one of those is the longest? Well, by picture, it looks like 12 is the longest, but let's make sure. 4 square root of 5 is 8.9. So yes, 12 is my biggest side. So I'm going to compare 12 squared to the other 2 sides squared and added together. Now, we talked about this as well in the radical review. 4 radical 2 squared. Be very careful with that. You have to square both the 4 and the radical 2. So 4 squared is 16. Radical 2 squared is 2. So 16 times 2 is 32. 4 radical 5 squared, you got to square the 4. 16 times 5 is 80. 12 squared is 144. 32 plus 80 is 112. So 144 is bigger than 112. If C squared is bigger, triangle ABC is obtuse. Okay. And that concludes our video for lesson 1 of unit 7.